Let's talk about waves. I'm sure most of you have heard this term tsunami before. It's a Japanese word which is used to signify a very particular type of phenomenon that takes place sometimes in coastal regions. You will see the ocean receding from the beach. You will be able to see coral reefs that you never saw before. The bottom of the sea is visible to you. And then all of a sudden, you see this wall of water coming towards you, which can reach a height of over 15 meters. Tsunamis can cause unbelievable destruction to coastal regions, and they happen every now and then and are often associated with earthquakes taking place in the ocean. The tsunami is a very destructive example of a wave phenomenon. Waves are something that you will encounter in physics again and again in various disparate disciplines. You will encounter waves when you are discussing sound, you will encounter waves when you are discussing electromagnetics. So, this is a very general class of phenomena. So, what exactly is a wave is the question that we are going to answer in these lessons. So, we were talking about waves. So, what exactly is a wave? We can consider a wave to be a disturbance taking place in a medium which is altering certain properties of the medium. This is not a complete definition, but this is applicable to the kinds of waves you observe in mechanical objects. For example, the ripples of water across a pond are an example of a mechanical wave. Sound is an example of a mechanical wave. And all of these mechanical waves have certain characteristics in common. Let's try to understand what these characteristics are. So, as I mentioned before, we are dealing with some kind of a disturbance in a medium. That disturbance can involve any physical parameter or any physical property of the medium. For example, let's look at water waves. What is happening in a water wave? If you look at a pond which is undisturbed, you will observe that that pond has some mean height of water, right? So, this will be the mean height of water, the undisturbed height of water or depth of water for that pond. When you cause a disturbance in the pond, for example, if you throw a rock into the pond, this particular quality or property of the water changes. For example, you observe that the height of the water is first increasing, then returning to zero, and then decreasing below the mean value of the depth of the water. Not only that, you also observe that this disturbance is propagating outward from the point of impact in all directions. So, this gives you a pretty good idea of what a wave phenomenon involves. It involves a change in some property of the medium, and this change is propagating from one point to the other. The other important quality of a wave is that while there is a transfer of energy and momentum from one point to the other, there is no physical transfer of actual matter between those 2 points. For example, the water molecules in this region of the wave will not be traveling outwards. They will be oscillating or they will be moving up and down in the same place again and again. And you could verify this experimentally. For example, if you had a toy placed at one of the heights of this wave or the crest of this wave, you would observe that it was going up and down, but it would not move forward or backward. It would pretty much stay exactly where it is, because in this particular wave, there is a transfer of energy and momentum, but there is no actual transfer of matter. So, the heights that these waves reach are known as the crests. These are known as the crests. Then, the wave actually goes below the average height of the water. So, these depressions are what we call troughs. So, in this particular case, for this particular wave, the property that is changing is the average height or depth of the water. The disturbance will move outwards from the point of impact at a certain speed, and the change in the average height of the water will happen cyclically again and again in a repeating pattern. The distance over which this is happening, the distance over which the wave goes through one complete crest and trough, is what we call the wavelength of the wave, which is denoted by the symbol lambda. The height of the crest or the depth of the trough gives us the amplitude of this wave. So, a stronger wave will have a larger amplitude and a weaker wave will have a smaller amplitude. Where else can we see the wave phenomenon? In this particular case, we are observing the change in the depth or height of the water due to an external disturbance. Another very common example of a mechanical wave that we encounter in daily life is the sound wave. So how does a sound wave work? A sound wave is in essence the variation of the pressure of the air medium between you and the source of the sound. So let us say that we have a speaker placed at some point in a room and there is a listener, or more accurately the listener's ear, which is detecting the sound. There is going to be a series of wave disturbances propagating between the speaker and the listener's ear. And what is varying here? What is the change here? We are going to observe that there is a change in the pressure of the air medium at each point between the source of sound and the receiver. Not only that, we also observe that the pressure will increase beyond the average value and then go below the average value, and this will happen repeatedly or cyclically. If we were to plot the pressure of the air as a function of distance from the source of the sound, we would observe that in some regions there is increased pressure, while in other regions there is decreased pressure, and this disturbance, this change in pressure is also propagating in the forward direction. So we observe that even different types of mechanical waves have certain properties in common. They will all have a wavelength, they will all have an amplitude. The amplitude can be the physical height of the wave, as in the case of water waves. It can be the maximum variation of pressure that we see in sound waves. They are also propagating from one point to the other, and just like the previous case of the water waves, there is no physical movement of actual air particles from one point to the other. A wave will transfer momentum, it can also transfer energy, but it is not going to transfer actual matter from one point in the medium to another. So these are the basic properties of the wave: the amplitude of the wave, the wavelength of the wave. There is another quantity that we have to understand, another quality of the wave, that is the frequency of the wave. We can understand frequency as the number of times the wave is fluctuating between the peak values every second. Or we can say the number of times a wave undergoes a complete cycle in unit time or during a period of 1 second. For example, we say that humans have a lower threshold of 20 Hz frequency. What does that mean? It means that the lowest amount of sound, the frequency of sound that we can hear, will involve a sound source which is oscillating or going up and down a minimum of 20 times every second. It is undergoing 20 complete cycles every second. As the fluctuations increase per unit time, the frequency of the wave is increasing. Now that we have understood these basic qualities of the wave, we are going to apply mathematical analysis to understand waves in more detail. Stay tuned.
Manorama Horizon. Learning made simple.